Show that the derivative of sine squared of x over 1 plus the cotangent of x plus cosine squared of x over 1 plus the tangent of x is equal to negative cosine of 2x. In previous math classes, you may have gotten questions where they show you a trigonometric expression on one side, and you have to simplify or manipulate it with different trig identities to make it equivalent to the other side. This problem is really similar to one of those questions. The only difference is that we have to take the derivative of our left side here first. So let's figure out how to do that. Then we can manipulate it to look like the right side. So let me copy down our left side. We have d over dx of, let me make it a little bigger actually. D over dx of sine squared of x over 1 plus the cotangent of x. And to that we add the cosine squared of x over 1 plus the tangent of x. So let's start thinking of ways that we can try simplifying or manipulating this expression. So I want to take a look at the denominator. Why? Because it's a little more complicated, so there might be ways to simplify this 1 plus cotangent of x or this 1 plus tangent of x. So let's start with what we know. One thing we know is that the cotangent of x is always equal to cosine of x divided by the sine of x. And we know that tangent of x is just the reciprocal of this. So tangent of x is equal to sine of x divided by cosine of x. So I know it'll make our expression look a little messier if we plug it in, but it'll work out because we're going to manipulate the 1 later. So let's plug this in for cotangent of x and tan of x. So this is equal to the derivative of and the reason we're trying to simplify it first is that it'll be a lot easier to take the derivative of it if we do that first. So we have sine squared of x over, let me make sure I have enough room, 1 plus cotangent of x is cosine of x over sine of x. And to that we still have our cosine squared x in the numerator, so we'll leave that be. And in our denominator, we have 1 plus sine of x over cosine of x. So this denominator is looking a bit messy. How can we add this 1 to our denominator fractions over here? Well, we can just make 1 have the same denominator of these little fractions. So for example, this one, it would be sine x over sine x, and this one, it would be cos x over cos x. So let's write that out. Let's write out all the steps so we don't get confused. So we have d over dx, got our big bracket there. We'll put in sine squared of x because we still have that in our big fractions numerator. And in the denominator, let's make this a little bigger actually. You know, let's move over the sine squared x. So sine squared of x, and in the denominator we have 1 can just be written as sine of x over sine of x, right? And to that we're adding cosine of x over sine of x. So let's do the same for this side here. I'm just showing you all the steps so that you can see where this is coming from, so that there's no confusion. So we still have our cosine squared of x in the numerator. In our denominator here, we want this to have the same denominator as sine x over cos x, so we'll just make 1 cos x over cos x. And to that we add sine x plus cosine of x. And that is equal to, still have our derivative out here. I'll just show you the added form. I won't show you the multiplication yet, but I'll just show you the slightly more simplified form before we simplify it even further. You'll see what I mean. So in our denominator here, we have sine x plus cosine of x, and that is all over sine of x because we've got our common denominator there. And here we've got our cosine squared of x still in the numerator. And let's just switch the order of this so that it matches this one. We have sine of x plus cosine of x over our common denominator, which is cosine of x. So, what do we do when we're dividing something by a fraction? We multiply it by the reciprocal of that fraction. So, right? So we are just, let me put this in brackets so it's a little clearer. So we are going to take sine squared of x and multiply it by the reciprocal of this. What is the reciprocal of that? The reciprocal of this is sine x over, should have made this a little longer. So we have sine x in the numerator and sine x plus cosine of x in the denominator. That is this part. And we are adding to that. We've got our cosine of x in the front here, and we have to multiply cosine squared of x by the reciprocal of this. Very similar to this. So we're multiplying it by cosine of x over sine of x plus cosine of x. And we can't forget our big green bracket. So let's do some simplification. All right, so we have d over dx. So what's sine squared x times sine x? Well, that's just sine cubed of x, right? If we have x squared times x, that just becomes x cubed. So we will have sine cubed of x in our numerator. And the denominator of this is just 1, by the way. So in the denominator, all you have is sine x plus cosine of x. And to that, we are adding similarly, this cosine squared of x, we're multiplying it by cosine x, so that just becomes cosine cubed of x. And in our denominator, we have sine x plus cosine of x. Now this is pretty helpful for us. Look, we've got two fractions with the same denominator. That means we can just add them. We can just add the numerators and keep them with the same denominator. So let's see, this is equal to d over dx of, sine cubed of x plus the cosine cubed of x over sine x plus cosine of x. All right, this one's interesting. How do we simplify this? Well, all we have to do is remember, what is a cubed plus b cubed equal to? This is our sum of cubes rule. We know that a sum of cubes, a cubed plus b cubed, is equal to a plus b over a squared minus ab plus b squared. If this is new to you, all you have to know is that if you multiply these two expressions, you indeed will get an a cubed out here, right? Because you have this a times the a squared that's here. This b will multiply with this b squared to make b cubed. And if you do all the expansions, any ab terms that you get, or a and ab squared, those terms, they will cancel out. Why is this helpful for us? Well, you'll see. If we say that sine x, let's write this down. Let's say a is equal to sine, oh, let me make that a little neater. Let's say a is equal to the sine of x. B is equal to the cosine of x. So what do we have here? We have sine cubed plus cosine of cubed of x. So we can just put this, which is an a cubed plus b cubed form, into this form, which is a plus b times a squared minus ab plus b squared. Why does that help? Well, here we have a plus b, right? Sine x plus cos x. So we can do some canceling. So let's write that out. So we have d over dx of, let's see, so we have a, which is sine x. Let me do our fraction line. And let me just move this over. So let's say this is a, and we are adding cosine of x to that, because cosine of x is our b. All right, now we have to multiply this. What is a squared? Well, that's just sine squared, because a is sine x. So a squared is sine squared of x. What is negative ab? Well, that's just negative sine x times cosine of x. And I think you're getting the hang of this by now. What is cosine squared? Oh, I'll give you the answer. What is b squared? It's cosine squared of x. And in our denominator, all we've got, we didn't do anything to our denominator, we've got sine x plus cosine of x. So do we see any way that we can simplify this? Well, we have a sine x plus cos x in the numerator. It's a factor of the numerator. And we have that in the denominator as well, so we can just cancel those out. Bye-bye to that, and bye-bye to that. We are almost in the final stretch here. So d over dx of sine squared of x minus sine x cosine of x plus cosine squared of x. All right. Are there any other ways to simplify this? Well, I do see one way. I wonder if you see it. So we've got, let me rewrite this actually. So we have a sine squared and a positive cosine squared, right? So addition, subtraction there. As long as you leave the sign in front of the term, you can switch around the order, right? So we have sine squared x, you can add that to cosine squared of x, and we'll have our negative sine x cosine of x out here. Well, what is sine squared plus cosine squared x equal to? That's just equal to 1, right? That's our Pythagorean identity. In case you don't remember, if you imagine your unit circle, right? On your unit circle, the radius is always equal to 1. Your cosine of x is the horizontal distance, and your sine of x is the vertical distance. So sine squared of x plus cosine squared of x equal to 1. In case you needed a reminder, so we'll put a 1 out here. And what about sine of x times cosine of x? Well, I remember one identity. Let me do an aside here. I remember the identity that sine of 2x is equal to 2 times sine x cosine of x. Well, ignoring the negative here, we have sine x cosine of x. So this must just be half of that. So if you take the half of both sides, multiply both sides by 1/2, half of sine 2x is equal to sine x cos x. Oh. And this helps us because then we don't have to use our product rule, right? Your product rule, you have to take the derivative, multiply, there's a lot of parts. So it's a lot easier to just use our chain rule, right? Just have one thing to take the derivative of. So let's plug in negative 1/2 sine of 2x. So we have 1 minus 1/2 of sine of 2x. Ooh, and that, I think, is all the simplifying we can do. Now we just take the derivative. Ooh. So what is this equal to? Well, if we take the derivative, well, I showed you all the steps so far, I might as well show you this step. So this is just equal to the derivative of 1. You might remember that the derivative of a constant is just 0. And we can put this negative out front. In fact, this whole constant out front. Let's put that up front. 1/2 times the derivative of sine of 2x. So what is this equal to? We know that the derivative of 1 is just 0. Well, if we remember our chain rule, we know that the derivative d over dx of f of g of x, gotta stay consistent with the colors here, is equal to the derivative of f with respect to g, right, multiplied by the derivative of g. So let's use that. So what's our outer function here? Our outer function is f of x, right? So f of x is equal to sine of x. And what is f prime of x? Well, the derivative of sine of x is just cosine of x. So what is f prime of g of x? Well, we can just plug in g of x where we have x. So for f of x equals sine of x, f prime of g of x is just equal to cosine of 2x. We just have to multiply it now by g prime of x. So what is g of x? It is 2x. What is the derivative of 2x? Well, that's just 2, right? You can think about it with the power rule. We can decrement x to the 1. It becomes x to the 0. 2 times 1, just 2. Or you can imagine a line with the slope of 2. The tangent to that line will always have a slope of 2. So g prime of x is equal to 2. So let's plug that in. So we still have our negative 1/2 out here. And in our brackets, we've got, let's see, we have to multiply these two things. So we've got 2, I'll put the 2 out front just because it's constant, times cosine of 2x. So this 2 and this 2 definitely cancel out, right? So this just becomes a negative 1 in front. And we deserve a big drum roll here. We get negative cosine of 2x. And what did we have to prove that our left side was equal to? Negative cosine of 2x. Alright, I hope that helped.